Okay, let's look at 9-5, simplifying complex numbers. All right. So remember, every number is a complex number. We'll get to that too again, in the form a real plus an imaginary. Now let's go through what I is. So remember, I is just the square root of -1. All right, that's pretty easy. And in 9-6, I'll show you why that is the case. So I to the first is just 1. All right. I squared, right, which is -1 square root of -1, the whole thing squared. The square root and the square go away, so that's a -1. Right? I cubed now. So I cubed technically would be I squared times I. Right? Same exponent properties. If I multiply like bases, I actually add the exponents. So this is I squared times I, which is I cubed. Well, I know I squared is -1, so that's why I get a -1 times I. That's why it's a -I. Well, I to the fourth can be written I squared times I squared. I squared is -1. I squared is -1. -1 times -1 is +1. Right? And this whole process repeats over. Because if I looked at it, I to the fifth would be what? I to the fourth times I. Well, what's I to the fourth? It's 1. 1 times I is simply I. And you'll see I start all the way back to the beginning. So there's really only 4 pieces of this pattern, and they repeat over and over and over. Which means if you want to simplify anything, figure out how many 4s, right? I to the fourth there are, because that's just going to be 1. All right, and I'll show you how to do all that. Okay, complex numbers. All right, remember, every number is a complex number, right? Real, imaginary, because the complex number has a real part and imaginary part. So if it was just 6, it means the imaginary number is 0. Right? If it's just 2i, it means the real part's 0. So every number you see is imaginary. All right? It has a real part and an imaginary part. Right? The imaginary part is the b. Right? The I lets you know it's imaginary. Okay? All right, so let's get back to, we'll use that a little bit later. Let's simplify something like this. I to the 5/3. Or 5/3, 53. So I to the 53rd. Right? Well, what I want to do is figure out how many times does 4 go into 53. All right? So 12 would be 48. 13 would be 52. So this can be written I to the fourth, times 13 times I. All right? So if I rewrote it, you'd see this is I to the 52 times I. Multiply like bases. This is I to the 53rd. Okay, but I don't want to do that. I want it in the split up form. Because what is I to the fourth? Well, if you look back, I to the fourth is just 1. So this is really 1 to the 13th power times I. Anything, and 1 raised to anything is just 1. So this is simply I. So I to the 53rd will divide I. Okay, so find out how many I to the fourth there are, and then you can get rid of all those. All right, well, let's see this. There are a couple ways to do this one too. Right? Just like any math problem, you can do it a bunch of ways. I'm going to show you just one. So what I can do, again, is figure out how many fourths there are. Well, I know there's -5/4. All right, so this would be I to the -20th. All right, and how many times I to the -1? All right, because I want them to add up to be I to the -21st. All right, well, this is still 1. 1 to the -5th power. Just 1. So this equals I to the -1. All right. So now I can't leave it I to the -1. So remember, a negative exponent means that anything on the top goes to the bottom, anything on the bottom goes to the top. So it's really I now to the +1. And after this, I'm not going to write that 1 anymore. So it's a negative exponent, which means it moves the whole base down to the bottom. Well, you can't leave, i's are like radicals in the sense that you shouldn't have them on the bottom. All right, so what I have to do to get rid of the I is I'll multiply top and bottom by I. You get I over I squared. Remember, I squared is 1, -1. So anything divided by -1 is just negative. All right, so it turns out that I to the negative 21st is just negative I. All right. Okay, let's add up some pieces here. All right, so I have a negative 3, which is the real part, plus 4i, 4 imaginary parts. Distribute this positive 1 through, you get plus 4 minus 5i. Okay, normal algebra rules apply here. Collect like terms. I have negative 3 reals plus 4 reals. I'm left with 1 real. I have 4 imaginaries and negative 5 imaginaries. I'm left with negative 1 imaginary. Alright, so just distribute your plus term. Add them up. Okay, let's look at the next one. I have 5 reals, 8 imaginaries. Distribute your plus. So I have a negative times a negative 3 is a positive 3. A negative, oh, that should be an I, not a whatever it looks like. A negative times an I is negative I. So I have 5 reals. 3 more reals is 8. 8 imaginaries minus 1 imaginary is positive 7 imaginary. Alright. Okay, if you have a FOIL problem, so 2 binomials multiply together, same thing. FOIL like you normally would. Negative 2 times 1 is negative 2. Negative 2 times a negative 2i. Right, the reals go together. Negative 2 times negative 2 is 4. I comes along. 4i times 1 is just 4i. And now 4i times negative 2i. 4 times negative 2 is 8. I times I squared. Alright. Okay, well, negative 2 plus, I can combine these terms, right? They're both imaginary. And what do I know about I squared? Well, it's negative 1. All right, so I squared is negative 1. So go back to the first page. Remember, if I is square root of negative 1, well, square root is, or square is square root, you just get negative 1. Get the inside. All right, so now I have negative 2 plus 8i plus 8. Now you'll see I have 2 reals I can put together. 6 plus 8i. All right. Okay, how about if we have a fraction here? Well, I want to get rid of the I. Just like a radical. How did I get rid of a radical in the denominator? I multiplied by the conjugate. All right, which is take the exact same term in the denominator, switch this on the inside. All right, let's do the top first. So I have 2 times 2i times 1 is 2i. I have 2i times 3i is 6i squared. On the bottom I get a 1. You get plus 3i minus 3i minus 9i squared. Alright. So, the top I have 2i plus 6 times negative 1. Alright. The bottom you'll see the positive 3i and the negative 3i will cancel out. Alright. That's why I took the conjugate, because that will always happen. So I'm left with 1 minus 9i squared, which is a negative 1. Alright. So I'll go down from here. So I get 2i minus 6 over 1 plus 9. Alright, I'll just rearrange it because it goes of reals come first, then imaginary. So negative 6 plus 2i all over 10. Alright, so I just put the real first. So it was negative 6 first. So it goes real, imaginary. So I would just nomenclature to write it. Now you'll see I can take a 2 out of everything. So it'll be negative 3 plus I all over 5. Alright, so that's how you simplify complex numbers.